Hello dear Goenkans. Today our topic is algorithm and flowcharts. It's the chapter number 10 of your textbook ITPs. So today we'll start with algorithms. You know what algorithm is? Algorithm is nothing. It is just a set of rules that will specify how a particular problem is to solve, how we solve some particular problems. Those particular problems can be anything. They can be logical problems, they can be mathematical problems, they can be simple problems, they can be complex problems. To make you understand what an algorithm is, and let's just take an example and see how we perform a specific task. Say for example, process of brushing our teeth. So process of brushing our teeth involves few steps. So we'll go from step 1 up to end. So let's just start. First, what we will do is we'll take our brush from the shelf or the brush holder, wherever it is. We'll turn on the tap. We'll turn on the tap of our wash basin. Second step. Then we'll resin our brush and we'll turn on the tap. Then we'll apply the toothpaste on the brush and we'll start brushing. So these are and after completing the brushing, we'll clean our brush and we'll resin our mouth again. So this is how we do the brushing. You have to follow these steps particularly one after the another in order to perform brushing, this process. We cannot be first applying toothpaste on the brush and then we can be rinsing the brush and our mouth with the tap. No, it has to be in one way. It cannot be in so many ways. So we have to be very particular about it. Similarly, to solve any problem on a computer, we analyze and understand the nature of the problem first. Then we'll plan the input, we'll apply some methods on the input, and we'll see how we can get the desired result by performing some methods step by step. So this step by step procedure to solve any problem is called algorithm. So we can say that algorithm is a set of sequential steps to solve any logical or mathematical problem. In our algorithm, few things should be there. The main important thing is our algorithm has following characteristics. Our algorithm must be having some input. So each algorithm should have some input that on which the work will be done. Then when you are giving some input, your input will be expecting some to produce at least some result. That will be our output. And in our algorithm, there should be definiteness. Definiteness is like your instructions that comprise your algorithm must be clear and unambiguous. Then there should be finiteness also in your algorithms. That is, if an instruction of an algorithm are executed, the algorithm should terminate after a finite number of steps. For example, if your algorithm contains 10 steps, it should end after those 10 steps with the result. It should not go infinite time. So there should be a termination to it. Now, the next thing is the algorithm and flowcharts. If we talk about them, they have three type of control structures within which they work. The very first is sequence. In sequence structures, statements are placed one after the other and the execution takes place from up to bottom. So it means as we already discussed an example, that is brushing the teeth, we have to first take the brush and then we have to turn on the tap of the wash basin. Then we have to raise in the brush and apply toothpaste on the brush, and then we have to start the brushing. So these are the steps that has to be followed one by one after other. We cannot follow it from down to up. No, we have to go one by one according to the structure, according to the statements that are placed one by one. So branching is selection. In branching, what we do is, in branching there is a condition, and according to that condition, if a statement is true, one value is placed. If a statement is false, the other one is taken. Or generally, if we say, for example, let's take an example of marks. We say if marks is greater than 80, then give A grade. If marks is less than 80, then give B grade. If marks are less than 70, then give C. So these are some statements that we use in branching. Or we say, if the child has occurred less than 5, he is failing. If a child has occurred more than 5, then he is passing. It is like an example of true or false. Then the other one is loop. Loop is repetition. We can also allow a statement to be executed until and unless the loop condition doesn't become false. Once it's false, the result will be outputted. For example, say we say I is equivalent to, say for example, if I is less than 2, then only I is a variable, I'm giving value to I, and then I'm writing a statement, and if my I value is equivalent to 5, then only write this statement. If not, then stop the loop and say that this loop is wrong. So it means that I will be executing unless and until it won't be equal, or it won't satisfy the condition. So that is loop, where we use repetition. We'll be discussing some algorithms, how to do it, and even I'll be sharing a PDF with you all to understand the concept of algorithms. Now the next is how we write an algorithm. The first step is we define our algorithm's input. That is the very first step when we are writing an algorithm. There must be, our algorithm data has to be first given. Say for example, if we want to calculate the area of a rectangle, we have to input first the height and the width of the rectangle. Then only we can calculate the area of the rectangle. And once we are giving height and width of the rectangle, then we have to divide the variables. The variables allow you to use it for more than one places. When I'll define two variables for rectangle, height and width, then only they'll be taking two values as input. And we should remember that we should use meaningful names for our variable names. We should not be using some names that are meaningless, say h, w. So if I'm using height and width, I should be using height and width as variables. After that, there should be then we have to give the algorithm operation. We have to give some operations to perform on our input. That then only we can get the output as result. So if I'm giving an algorithm in which I'm giving width and height, then I have to give an operation that how we can get the area of rectangle using width and height. In the operation, I have to define some kind of method to it where it will calculate the value. So I have to write there that height into width is equivalent to area. After giving the operation, it will give us the desired output. Okay, so for example, if we have given height is 2 and width is 3, the algorithm would give us output of the value 6. And after this, I have already written few algorithms step by step. Say for few examples of the algorithms that has to be performed, like algorithm to set your school bag, algorithm to calculate the sum of two numbers. Let's just see this. If we algorithm to calculate the sum of two numbers, we have to first input a number. Say for example, let's just do the rough work. I'm inputting a number A. The second step is input a number, second number B. Let's just say C. Step 3, find the sum of the two numbers, that is in the sum. Sum will calculate the sum value, that is A plus B, that will become 5. So after that, print sum. So this is how an algorithm will be executed in the computer. Likewise, there is another one algorithm where we are comparing two numbers and finding the greatest one. Start. Input two numbers and store them in A and B. Let's just write two numbers, 5 and 89. And then check whether A is equivalent to B or not. So let's just check. A is equivalent to B. No, A is not equivalent to B. If true, then go to step 4. So if A is equivalent to B, it will go to step 4, that is print. So it has a print statement over there which says both numbers are equal. So if our A and B are equal, it would have given an input, that is both numbers are equal. No, if true, then go to step 4, else go to step 5. So let's just go to step 5, that is again compare A and B. If A is greater than B, then go to step 6, else go to step 7. Let's just see, is A greater than B? No. So we have to skip step 6 and then we have to print step 7, that is B is greater. So our output will be B is greater. This was all about algorithms. Hope you understood it, and I'll be sharing a PDF in which I'll be giving all the study material related to the algorithms. Take care. Goodbye.